Today we're looking at properties of real numbers. So both the commutative property, the associative property, and the distributive property we're going to take a look at. So first, the commutative property is when we have something like a plus b, we could rewrite that using saying b plus a, meaning that the terms for addition can be rearranged. A plus b, b plus a, or a plus b plus c is equal to c plus a plus b, just rearranging the terms when we're adding. 2 plus 3 plus 4 is the same thing as 4 plus 3 plus 2. You can rearrange when you're adding. You're going to get the same sum no matter what order that you add in. Same thing with multiplication. So if I have a times b, that is the same thing as b times a, or more specifically, 5 times 6 is the same thing as 6 times 5. You're going to get 30 either way. That's the commutative properties of addition and multiplication. Now that doesn't apply for subtraction. Like you can't do 3 minus 2 and that be the same thing as 2 minus 3. Not the same thing. 3 minus 2 is 1, where 2 minus 3 is negative 1. Not the same answer. So we can't do that for subtraction. Same thing with division. You can't do 3 divided by 6 and that's equivalent to 6 divided by 3. That's not true. Those are not equivalent. So we don't have the commutative properties for subtraction and division. It is only for addition and multiplication. Let's do some examples. So number 1, x plus 9 can be rewritten as 9 plus x. And those are not like terms or anything. So we would just leave it as 9 plus x. 6 times x can be rewritten as x times 6. Now that's typically we would just leave 6 times x as just 6x, 6 times x being 6x. But it is good to understand that the commutative property does apply there. We can rearrange it x times 6 because there are some scenarios where that might be a little bit more helpful, where we can rearrange the multiplication to maybe do it a little bit more mental, maybe make the mental math a little bit easier in some cases. The associative property. The associative property is when we have grouping, so like parentheses. So if we had a plus b plus c, that is equivalent to a plus b plus c, but then we put the parentheses around the b plus c, so we do that first. So the parentheses, order of operations, indicate what we do first. The a plus b first here, and then we add on c after that. Where here, if I have the parentheses here, b plus c, and then I add on a. We're going to get the exact same sum, though. It's going to be the exact same answer. We're just doing it in a different order. Just like how we talked about the commutative property, we can rearrange the numbers. For associative property, we can regroup if it's all of the terms are being added together. Same thing with multiplication. If you have a times b times c, where we're doing a times b first, we can also do a times b times c, where we do b times c first. So in the example, number 3, 7 plus 3 plus 2, we can rewrite that as, now the numbers don't switch order. Like I'm leaving it as a, b, c, so I'm leaving it as 7, 3, 2. So it would be 7 plus 3 in parentheses plus 2. So I would do the 7 plus 3 first and then add on the 2. Then number 4, 6 times negative 1 times 8, I can regroup that as 6 times and then just do negative 1, and I just wrote negative 8 as I was saying negative 1, negative 1 times 8. So I do negative 1 times 8 and then I'd multiply that by 6. Same thing as 6 times negative 1, then multiplying by 8. So just being able to rearrange the terms around. Let's use these properties to simplify these expressions. Number 5, we have 5 plus x plus 6. I can rearrange this. I can do this a couple different ways, but first what's jumping out to me is I could rearrange the 5 plus x. And I know they're being grouped where you do the x plus 6, but we can't really do x plus 6 because those are not like terms. So I can rearrange this as x plus, and then in parentheses, 5 plus 6. What is 5 plus 6? 5 plus 6 is 11, so then you'd have x plus 11. So we could simplify it that way, where we can just rearrange the terms around, and then that 5 and 6 are in the grouping, which we just do 5 plus 6. And then number 6, negative 9 times 6x, I can't do 6 times x, like it would just be 6x. So I can regroup and say negative 9 times 6, and then have the x. So what is negative 9 times 6? Negative 9 times 6 is negative 54x. So then that would simplify to negative 54x. Just being able to use those properties to rearrange. Distributive property. So the distributive property is if we have 3 times, let's say, x plus 10. So I have a number or term, number, variable, it doesn't matter, being multiplied by another greater term. Like this is multiplying by x plus 10. So this is 3 times whatever x plus 10 comes out to be. For example, let's just say I have this example, 3 times x plus 10, and I say x is equal to 1. So I'm saying x is equal to 1. So I'd have 3 times 1 plus 10, then I'd do the grouping, 1 plus 10 is 11, so then I'd have 3 times 11. 3 times 11 is 33. But when I don't have x being actually equal to something, like in this example, I just have x plus 10, so I want to distribute the 3 to the x, because I want to do 3 times x, and then 3 to the 10. So I'm going to do 3 times 10, and then that sum would work out the same, just like here. If I did 3 times 1, 3 times 1 is 3, plus 3 times 10 is 30, 3 plus 30 is 33. See how we get the exact same answer? But using a distributive property, I could do 3 times x, and then 3 times 10 to get 3 times x. This is a 1, so this is 3 times 1x. 3 times 1 is 3. 3 times 1x is 3x. 3 times 10 is 30. So I just distribute to all of the terms. And number 7, 7 times x, 7 times 2. So 7 times 1x, when we're multiplying, we just multiply the coefficients. So 7 times 1. 7 times 1 is 7, so that's going to be 7x. Plus 7 times 2 is 14. So 7x plus 14. Let me erase some of this here. Get a little jumble up here. Let me erase this whole. I don't want it to be too messy. Next one. We have negative 6 times 3x plus 6, and then we have that plus 2. So we have negative 6 times 3x plus 6 plus 2. So I'm distributing negative 6 to the 3x, negative 6 times 6. Am I going all the way to the 2, though? No, I'm not. I am not multiplying negative 6 times 2 because it's just negative 6 times this whole term right here. So whatever x ends up being, if x is equal to 3, you would plug in 3. You do 3 times 3 plus 6 times negative 6. You wouldn't add on that 2 until you performed this entire step right here. Once you do this entire step right here, then you would add on the 2. So I'm going to distribute the negative 6. Negative 6 times 3 is negative 18x. Negative 6 times 6 is negative 36. Then we have that plus 2. And in this case, we do have some like terms that we have to simplify. You have to simplify the negative 36 plus 2. These are like terms because they're just constants. They don't have a variable attached to them. So we are going to do negative 36 plus 2. Negative 36 plus 2 is, one's a negative, one's a positive, so 36 minus 2 is 34. 36 was bigger, so it's going to be negative. So negative 18x minus 34. On number 9, we have a multiplication of 5 times 3 terms inside these parentheses. All 3 of these terms are in the parentheses, where compared to the last one, only the 3x plus 6 was in the parentheses, not the plus 2. So I'm doing 5 times 2x, 5 times 8y, 5 times negative 3. I'm multiplying that 5 through to everything. So 5 times 2x is 10x. 5 times 8 is 40y. 5 times negative 3 is negative 15. And this one, we don't have any like terms because this is an x, this is a y, and then this is just a constant without a variable. So those are all non-like terms, so we cannot combine anything there. Let's check out number 10. So I'm doing negative 2 times 7, negative 2 times negative z, and I am not distributing all the way to the negative 3, just distributing to the 7 minus z. So negative 2 times 7 is negative 14. Negative 2 times negative z is going to be negative times a negative is a positive 2z minus 3. We have like terms, but look where their locations are. This is negative 14 and this is minus 3. Those are like terms because they don't have any variables. So we could use the commutative property to rearrange the terms if we wish. We could rewrite this as negative 14 minus 3 plus 2z. And you get to a point where you don't have to rewrite, like I'm going to combine these like terms, so I'm going to rewrite this. You get to a point where you're going to have to do that, but just so you understand the concept of how this commutative property works together with the distributive property and how this all works together. So we're going to do negative 14 minus 3 is negative 17 plus 2z. There we go. So the next two, and I accidentally numbered them both 11 and 11. They were supposed to be just similar problems, but I thought they made a little mistake there, but that's okay. Number 11, the first 11, 10 minus, in parentheses, 4x plus 1. So what we want here is we want to subtract off this entire term. What do I have to make sure that happens if I'm subtracting off this entire term? I need to take the opposite of all those terms because I want to do minus 4x minus 1. I want to subtract off everything. We're on number 11 again, the second 11. I want to do 11 minus 2 times 10x minus 3. So I want to subtract off all of doubling these terms, but I want to make sure I'm subtracting it off. So what I have to distribute here, whoops, made that box a little bit too big. What I want to distribute here is the negative 2. I want to do negative 2 times 10x, negative 2 times negative 3. I want to multiply everything by that negative 2, where it's the same problem, almost identical, but here I'm just doing negative 1. If you want to think this is a negative 1, so this is negative 1 times 4x, negative 1 times positive 1, negative 2 times 10x, negative 2 times negative 3. This is a very common problem that I just see this mistake happen all the time, where students would do this. Like if I look at the second 11 here, students would do this. They would do 2 times 10x, 2 times negative 3. So you'd have minus 20x minus 6. Like you're not actually taking the opposite of negative 3 because you want to subtract off all that, so you want to take the opposite. So you want to make sure that's plus 6. So back to this first problem though. So I want to do negative 1 times 4, or take the opposite of 4x, negative 1 times 1, take the opposite of positive 1. So 10 minus 4x minus 1. Because negative 1 times 4 is negative 4, negative 1 times 1 is negative 1. And then we want to combine like terms. 10 minus 1 is 9. And you could write this as 9 minus 4x. And you could have rearranged it as 10 minus 1 using the commutative property, but just to save a little time there. You could write this as 9 minus 4x or negative 4x plus 9. You just want to make sure your signs are correct. This is a positive 9, so it needs to be plus 9. This is a negative 4x, so it needs to be, this is minus 4x, so it needs to be negative 4x. And then off to this problem here. I already kind of started working through it, but I'll go through it again. I want to do negative 2 times 10 and negative 2 times negative 3. So 11 minus 20x plus 6. So negative 2 times 10 is negative 20x. Negative 2 times negative 3 is positive 6. And then we have some like terms. 11 plus 6 is 17. So 17 minus 20x. Last thing I want to look at in this video is the addition and multiplication identities and the additive or multiplicative inverses. So the addition and multiplication identity is, think of it as just how do we get back what we have already. So what I mean by that is if I have, let's talk about addition first. If I have the number 5, what would I add to 5 to get back 5? I would add 0. 5 plus 0 is 5. I'm adding nothing to 5, so I get right back to where I started. With multiplication, what do I multiply 6 by to get back to 6? I multiply by 1. 6 times 1 is 6. That is the identity. And then the inverse is, it's not just trying to get back on a certain term, but the additive inverse is trying to get 0. So if I have 5 again, what would I add to 5 to get to 0? Well, I'd add negative 5. So the opposite of 5 is negative 5. So that'd be 0. 5 plus negative 5 is 0. And then the multiplicative inverse is going to be, if I have the number 6, so stay with 5s and 6s, what would I multiply 6 by to get to 1? So you see how these are kind of related here. So the addition identity was 5 plus 0, and then the additive inverse was getting to 0. The multiplication identity was 6 times 1. The multiplicative inverse is getting back to 1. So these are both intertwined here. So what we want to multiply 6 by is 1 over 6, the reciprocal. 1 over 6, because 6 divided by 6 is 1. So you get back to 1. These are used a lot in solving equations. That's why these properties are good to know and good to understand when you get to solving equations.